Okay, let's look at converting between decimals, fractions, and percentages, because you're going to need to convert between those as you're working problems in stats. Now, you can use a calculator for this, use a calculator to go from fractions, from fractions to decimals. Be sure to use the correct fraction for the place value. And remember that when you're going from decimals to percent, you're either multiplying by 100 or dividing by 100. So let's look at this table. In this table, I have fractions, decimals, and percents. And I give you one form. And then I want you to convert to the other two forms. So the first one, I give you a fraction. On the second number, I give you a decimal. And on the last two, I give you a percent. So let's start converting those. The first thing I want you to do is the fraction 7 over 20. I want you to just take your calculator out and divide. 7 divided by 20. And I've made these boxes big so that you can make notes to yourself and not just write the answer, but also make notes to yourself on how you got it. So you might want to write calculator in this box just to remind you. But when you transferred from here to here, from 7 over 20 to a decimal, you used a calculator. And your answer was 0.35. Now, to go from decimals to percents, you need to multiply by 100. So when you go from 0.35 to percent, you're going to multiply by 100, and that would give you 35%. Okay, on the second one, I give you the decimal value, 0.082. Let's do the percent first because that's really easy. You just multiply by 100. And if you'll recall, you can do it on your calculator, you can plug it in, but also multiplying by 100 increases the number by moving the decimal point 2 places. So this is 8.2%. Now, to get the fraction, what I want you to do, I'm going to use a different color here. What I want you to do is I want you to look at the position of the last digit. The last digit is in the thousandths place. So in order to get the fraction, you're going to write 82, which is the numerical part of the decimal that you had, 82, over 1,000. And that's your fraction part, and you don't have to reduce it here for me. But check your answer, check your math, take your calculator and divide 82 divided by 1,000 and make sure that you get, make sure that you get 0.082. Okay, last one. Last one, we're going to start with percent, which means when we move to decimal, we have to divide by 100. So 7 divided by 100 would be 0.07. I'll put a 0 in front of it. 0.07. When I look at the fractional part, when I want to make the fraction, the 7 is in the hundredths place, so that would be 7 divided by 100. And I'll check again. I'll do 7 divided by 100 and make sure that I get 0.07. And the last one, I'm going to divide by 100 to go from percent back to decimal. When I divide by 100, I'm going to get 0.003. I know that is not a number that you're used to seeing or whatever. I know it feels like maybe, oh, I went the wrong way or I did the wrong thing or whatever. But 0.3% is 0.003 in decimal format. And when I look at the 3's in the thousandths place. So this would be 3 divided by 1,000 would be the fraction. All right, now we're going to use the fraction, decimal, and percent format to complete a frequency table. Now we're going to be doing frequency tables in Unit 1. And a frequency table is really a count of how many parts of our sample were in a certain class where, in this case, 17 to 19 is an age class, the class of 17-year-olds to 19-year-olds. That's a class. And there were 9 students that were ages, this is a table of ages of students in a stats class. Okay, so there were 9 students. There were 11 students that were 20 to 22 years old, and so on. So what we're going to do is we're going to take this frequency distribution, which is really just took a list of ages and then made a table and separated all the students and their ages into the row that they belonged in because due to their age. Now, what we're going to do is we're going to convert that to a relative frequency. A relative frequency tells us the percent of the class that were in each of those age ranges. So we're going to be doing 3 different things. We're actually going to do, so leave yourself space. You're going to do the fraction, and then you're going to do the decimal, and then you're going to write the percent. So we're going to do all 3 on each row. And percent is really the one we normally use. But we're going to go through the other 2 to get there. Okay, the first thing we got to do is we got to figure out how many people were in the class. So N would be our sample size. That's the number of people that were in the stats class where we checked the ages. And the number of people is equal to the sum of the frequencies. That's an uppercase sigma, which means add them all up. So add up all the frequencies. And if you add these values up, 9, 11, 5, 3, 1, and 1, when you add up all those numbers, you get 30. So the sample size is 30. You're going to need that number. That number is actually going to be very important. It's the denominator of every fraction that you write. So let's start with the fraction form. There were 9 people that were 17 to 19 years old. That's 9 out of 30. There were 11 out of 30 that were 20 to 22, and 5 out of 30 that were 23 to 25, 3 out of 30 that were 26 to 28 years old, 1 person out of 30 was in the 29 to 31 year range, and then 1 person out of 30 was in the 31 to 33 year range. So here are our fractions. Now we're going to find the decimals. So just take your calculator and divide. Now what your instructions told you to do was give the fraction. We've done that. Now we're going to do the decimal form, rounded to 3 places. That's setting us up so that when we do the percent, we'll be in the 10th place on the percent. That's why we want to round to 3 places on the decimal, so we'll be rounded to 1 place past the decimal when we get to the percent category. Okay, so 9 divided by 30 would be, and this one's weird because what you really get is 0.3. But since it said round to 3 places, I'm going to go ahead and add a couple of zeros after that. 11 divided by 30 is 0. And I'm going to have to round off 367 because I got 0.36666, and that if I'm rounding to 3 decimal places, then I had to round that one in the thousandths place up. Okay, 5 out of 30 would be 0.167. 3 out of 30 would be 0.100. Again, I just added some more zeros to the end since it had said round to 3 decimal places. 1 out of 30 is 0.033. And again, 1 out of 30 is 0.033. And now percents. Percents, remember, are just multiplying the decimal by 100. So this would be 30% 33.0% and 36.7% and 16.7% and 10.0% and 3.3% and 3.3%. Now, a great way to check your work when you're finished is to add up all your percents, and all your percents should be approximately 100%. So add them all up and make sure that you did your work right. All your decimals should be approximately 1.0 when you add them up. It may not be exactly 1.0 because of round off, but it should be really, really close. And the percents may not be at 100. It may be 99.9% or 100.1%. That's okay. It's a round off issue. So just check your work on those. And that's it. Practice the ones that I've given you to practice on, and then check your answers.